Welcome to FNM Labs. We continue our 8th grade maths topics. Welcome back to this session on percentages. In our last session, we discussed about the meaning of percentage, how to convert a percentage to a fraction and a fraction to its representative percentage. We also discussed about the difference between x percentage of y and x as percent of y. We also learned how to find a change percentage, an increase percentage as well as a decrease percentage. In this session, the part 2 on percentages, we are going to discuss about how to evaluate certain expressions on percentages. Also, we will do a number of interesting real-life cases on percentages applying the percentage concept. So with that introduction, let's get into action. Have a great learning time. Let us recapitulate the key ideas we discussed in the part 1 of percentages. If you want to convert a fraction to its percentage form, you just need to multiply it by 100. Conversely, if you want to find the fractional form of a percentage, you need to divide the percent by 100. We then saw the meaning of x percent of y is x by 100 times y, and we saw some examples for that. We then examined what is meant by saying x as percent of y, which is nothing but x out of y times 100. So we understood 5% of 40 is 5 by 100 times 40. And 5 as percent of 40 is 5 by 40 times 100. We then learned change percentage, increase or decrease percentage. Increase percentage is increase in quantity by original quantity times 100, and decrease percentage is decrease in quantity by original quantity times 100. With these concepts in mind, let us discuss a number of cases where we can apply these ideas. So stay tuned. The third case we consider is evaluate 55% of 160 plus 24% of 50 minus 36% of 150. We remember the concept x percent of y, which is same as x by 100 times y. So applying this idea here, 55% of 160 is equal to 55 by 100 times 160, which is equal to 5.5 times 16, which is equal to 88. And 24% of 50 is equal to 24 by 100 times 50 is equal to 24 by 2, which is 12. Similarly, 36% of 150 is equal to 36 by 100 times 150 equal to 36 times 3 by 2, which is equal to 54. Therefore, the answer to the question is 88 plus 12 minus 54, which is equal to 100 minus 54, which is equal to 46. Coming to the next case, a man spends 87% of his salary. If he saves 325 rupees, find his salary. Here the question is, we need to find salary, and there are two actions happening. He saves some amount and spends some other amount, and we know the total salary of a person is amount spent plus amount saved. And here we assume his salary as some variable, say x. It is given that amount spent is 87% of his salary, so that is equal to 87 by 100 times x, as x is assumed to be the salary. It is also given that amount saved is 325. So substituting these values in the first equation, total salary equal to amount spent plus amount saved, we get the relationship as total salary, which is x, equal to 87 by 100 times x, which is the amount spent, plus 325, which is amount saved. Now bringing all the terms containing the variable x to one side, the left hand side, I get the equation becomes x minus 87 by 100 times x is equal to 325. Now on the left hand side, x is a common factor. So taking it outside of the bracket, we get x times 1 minus 87 by 100 is equal to 325. Now taking the LCM, we get x times 100 minus 87 by 100 is equal to 325. Now simplifying, we get x as 25 times 100, which is 2500 or 2500. The next case is a number 12 is wrongly read as 12.6. What is the percentage of error? Now before doing that, we need to form an idea how to do this. Now the question is, what is percentage of error? The percentage of error can be restated as error as percentage of correct value. So we have seen this, x as percentage of y. So we know how to find x as percentage of y, which is x by y times 100. So the steps we do for this are, 1, we need to find the error, and second, we need to write the error as percentage of correct value. So first aim is to find the error. So the correct reading is 12, wrong reading is 12.6. Therefore error is the difference between these two readings, wrong value minus correct value, which is 12.6 minus 12, that is equal to 0.6. Therefore percentage of error is equal to 0.6 as percentage of 12, which is equal to 0.6 by 12 times 100, that is equal to 60 by 12, which is 5%. So the percentage of error is 5%. The next case is, out of 800 oranges, 50 are found rotten. Find the percentage of good ones. Remember, it is always better to form an idea how to solve a case, as we did for the previous case. What is the question here? To find percentage of good oranges. What information is given for this? We are given with total number of oranges and number of rotten ones. So we need to find the number of good ones. We know that the total number of oranges is number of good oranges plus number of rotten ones. Therefore, number of good ones is equal to total number of oranges minus number of rotten oranges. So once we get the number of good ones, we can find the good ones as percentage of the total. So the steps are, 1, find the number of good ones, and 2, write it as percentage of total. So the total number of oranges is 800, number of rotten oranges is 50. Therefore, good oranges is equal to total oranges minus rotten ones. That is equal to 800 minus 50, which is 750. Therefore, percentage of good ones is equal to 750 as percentage of 800. So that is equal to 750 by 800 times 100, which is equal to 750 by 8, that is equal to 93 and 3 by 4, which is equal to 93.75%. So the number of good oranges is 93.75% of the total 800 oranges. Case number 7. In an election between two candidates, one candidate secured 47% of votes polled and lost the election by 12,366 votes. Find the total votes polled and the votes secured by the winning candidate. Here, the idea is, in order to get the required votes, we can make use of the votes by which he failed, which is given. So the steps are, first we need to find the percentage of votes secured by the winner. Then we find the difference of vote percentage secured by both the candidates. This will be the percentage of votes by which he lost the election. And thirdly, find this percentage of total votes and equate to the given value. So let the total number of votes polled be x, which is an unknown variable. Percentage of votes secured by the lost candidate is 47%. Therefore, percentage of votes secured by the winner is 100 minus 47, which is 53%. We know the total votes is 100%. Therefore, percentage of votes by which he lost will be the difference of secured vote percentages. The difference between 53 and 47, which is 6% of total votes. Since he lost by 6% of total votes, we can write it as 6% of x, that is 6 by 100 times x. And this is given as equal to 12,366 votes. So equating these two, we get 6 by 100 times x equal to 12,366. Therefore, x is 12,366 times 100 by 6, which is equal to 2,06,100. This means the total number of polled votes is 2,06,100. Therefore, votes secured by the winning candidate is 53% of the total votes, which is equal to 2,06,100 times 53 by 100, which is equal to 1,09,233. Let's move to case 8. This is about depreciation of a scooter, and we need to find the depreciated amount. The cost of a scooter depreciates every year by 15% of its value at the beginning of the year. If the present cost of the scooter is 8,000 rupees, you need to find its cost after 1 year, also after 2 years. Here the question is, find the cost of the scooter at the end of first year, also at the end of second year. So that the cost of the scooter is changed based on the depreciation amount. So the idea is we need to find the depreciation amount on the cost at the beginning of each year. And once we find the depreciation amount, we need to subtract that amount from the present cost to find the depreciated cost. So we start with the first year. The initial cost is 8,000. We know the percentage of depreciation for both the year is 15%. So the depreciation amount is 15% of 8,000, which is 1,200. So at the end of first year, the cost gets reduced by the depreciation amount, which is 1,200. So the cost at the end of first year is 6,800. Now we begin second year with this cost. So cost of the scooter at the second year beginning is 6,800. Again, the percentage of depreciation is 15%. So we need to find the depreciation amount for second year, which is again 15% of 6,800. That is 1,020. The cost gets again reduced by this amount, 1,020. So at the end of second year, the cost of the scooter is 6,800 minus 1,020, which is equal to 5,780, which is the answer. In this example, in order to calculate the cost of the scooter after depreciation, we first calculated the depreciation amount and then subtracted it from the cost of the scooter. Now the question is, can we find the cost of the scooter after depreciation directly without finding the depreciation amount in between? Now going through the calculation once again, at the end of the year, the cost of the scooter will be cost at the beginning of the first year minus depreciation for the first year. So that is equal to 8,000 minus 15 by 100 times 8,000. Now the 8,000 can be taken outside of the bracket. It becomes 8,000 into 1 minus 15 by 100. That is equal to 8,000 times 85 by 100, which is equal to 80 into 85. That is same as 6,800. So here, after the first year, we got the cost of the scooter after depreciation without finding the depreciation amount separately. In the same manner, we can calculate the depreciated cost of the scooter after the second year without finding the depreciation amount. we have cost after depreciation is equal to cost at the beginning of second year minus depreciation for second year. So that becomes equal to 6,800 minus 15 by 100 times 6,800. We are using 6,800 here, which is the cost of the scooter at the beginning of second year. Calculating in the same way, we get the cost of the scooter after second year depreciation amounts to 5,780. Thus, we can find cost after depreciation directly without finding depreciation amount. So in general, by the end of the year, cost after depreciation in the year is same as cost at the beginning of year times 100 minus rate of depreciation divided by 100. So we found it in the previous example as 8,000 times 100 minus 15 by 100, which gives the depreciated amount. So now we think, can we devise a direct formula for cost of the scooter after depreciation on third year? Let us calculate the cost after depreciation in the first year. So that is equal to cost at the beginning of first year minus depreciation for first year. So that is same as 8,000 times 100 minus 15 by 100, which is equal to 6,800. And this becomes the cost at the beginning of the second year. Now finding the cost after depreciation in the second year, we have cost at the beginning of second year minus depreciation for second year. So that is equal to 6,800 minus 15 by 100 times 6,800. That is equal to 6,800 times 100 minus 15 by 100. Now from the above line, we have 6,800 is nothing but 8,000 times 100 minus 15 by 100. So we can replace the 6,800 with this value. Now it becomes 8,000 times 100 minus 15 by 100 times 100 minus 15 by 100. 8,000 is the original cost of the scooter. The next part, 100 minus 15 by 100, stands for first year depreciation. And the next term, 100 minus 15 by 100, stands for the second year depreciation. Now thinking like this, we have a general formula for cost after depreciation on third year as equal to initial cost times 100 minus rate for year 1 by 100 times 100 minus rate for year 2 by 100 times 100 minus rate for year 3 by 100. Now we have a general direct formula for calculating cost after depreciation on third year. Now this can be extended to any number of years. So far we considered a case where the value of something is reduced by some percentage, and we know how to calculate the reduced value of the item. Now suppose a number P is first increased by X percentage and then decreased by Y percentage. Now is there any way to find the resulting number? Now in general, first P is increased by X percent means the new value of P will be P times 100 plus X by 100, and this is similar to the way we calculated the depreciated cost of the scooter in the previous example. So we now have the new value of P. Now as per the statement, the new value is now reduced by Y percentage. So now the new value after the depreciation or after the reduction will be P times 100 plus X by 100 times 100 minus Y by 100. And this is a general formula after reduction or after increase or together applying this formula. In this way, we can calculate the new value of an item. Let us discuss case 9. A number 12,000 is first decreased by 15% and then further decreased by 25%. Can you find the resulting number? So we can use the same direct formula here. Both the time the values get reduced. Therefore, final number after decreasing twice is equal to initial number times 100 minus rate 1 by 100 times 100 minus rate 2 by 100. Rate 1 and rate 2 being the first and second decrease percentages. So the value becomes 12,000 times 100 minus 15 by 100 times 100 minus 25 by 100. That is equal to 12,000 times 85 by 100 into 75 by 100. That is equal to 12 into 85 into 75 by 10, which is equal to 7,650, which is the answer. Next, let us consider an interesting case. Suppose number 8,000 is first increased by 20% and then decreased by 20%. Increase and decrease percentage is same. So the question is, will you get 8,000? What do you think? Find the resulting number. Here also we can use the same direct formula for finding out the resulting number. Number after x percent increase and then y percent decrease is equal to initial number times 100 plus x by 100 into 100 minus y by 100. So the final number will be equal to 8,000 into 100 plus 20 by 100 into 100 minus 20 by 100. That is equal to 8,000 into 120 by 100 into 80 by 100. That is equal to 80 into 12 into 8, which is equal to 7,680. So we started with 8,000, but the resulting number after 20% increase and then 20% decrease is 7,680, which is less than 8,000. Let us visualize this using a graph. First, the 8,000 amount is increased by 20% of 8,000, which is 1,600, and it reaches 9,600. And then it is decreased by 20%. Here the reduction 20% is based on 9,600, not on 8,000. So the reduction value is more than the increase value, which is 1,920. It gets increased by 1,600, but it gets reduced by 1,920. So it goes below 8,000 after reduction. So the final amount is 4% below the initial amount. We discussed a number of cases on this session. That's it for now. We will continue on this topic in the next third and final session on percentages. So meet you soon. Till then, have a great time.